In this tutorial, my name is Jeremy Comel from Innovative Omics. We'll cover how to get MSMS data aligned alongside of your IM ability data with the great power of FluoroMatch LC, which uses the MSMS data for annotations, identifications, things of those nature, alongside a FluoroMatch IM and combining those all into one visualization platform and result file. So first, you have to use PNNL's tool, or if there's another tool you're aware of, to generate a data-dependent analysis file, two-dimensional file, just like you would have for an LC file, from your LC IM DIA data, so all IANS data. So we need an LC DDA-like file, and so PNNL's tool does that, great for Agilent type files. So you'll generate those .d files. Then you also, if you can't get them as an MZML directly, want to export those as an MZML with your MSMS data. You'll also want to run FluoroMatch IM on your initial data, which will be your MS1 data with your MZML and your peak table that you get from your 4D peak picking. So you'll want to do that first, and you'll use those results. So let's go into how you'll use those results. So if I go into IM only, I ran my FluoroMatch IM, and I got the following results. We'll want all of these files for the visualizer, but the only one right now that I'm interested in is neg-ID'd fin. So the one that has all the annotations, the CCS matching, everything, the homologous series detection. We want all of that. And let's make a new folder. So let's call it modular, for example, or MSMS identifications, whatever you want to call it. And we're going to put that file here. I've renamed it as FluoroMatch IM output. In this case, it's some NIST data underscore neg. And then alongside of that, you don't need this file because we're only going to get EICs from previously. We already got them, so we won't do it. So all you need is the MZML file that you've exported, and you only really need the MS2 level data in this MZML. And you want to have DDMS2 underscore DDMS2 underscore in the name. You want to end in underscore neg, and there's your MZML. You can also use the .ms2 format as well. This output folder will be generated. Make sure to delete this if it's already there because you ran something previously before you run. So this is all you need for your input. If you have multiple data-dependent files, you can add all of them here. Just making sure they have the right annotation. So underscore DDMS2 underscore anywhere and underscore neg at the end. So those are your inputs. And then you're going to go into your software, FluoroMatch IM, and you see that there's this modular MSMS PNNL tool, and here's the code. And so you're going to open that up. And then if this is not already set to true, which it should be by default, you do want to set your IM first to true. And then the only thing you have to change in this file, so I opened it up and it went into RStudio because I have RStudio. If you don't have RStudio, you can go to Open With and then open it up in Notepad or text editor or something like that. Don't open it in Word because Word will automatically correct some things. So if you do Control Find and you go to Input, I guess probably not the best one to look at. Let's see. So let's do this, try this again. So let's say you opened it up and you're starting and you go to Control F CSV input. Still a lot of things. Or you could put CSV variables section when you do Control F. And that will bring you to the right place. But either way, you want to get to this else if CSV input equals true. And don't worry, you don't have to know coding for this, but this is the only thing you change. All you have to do is change the directory for which you get your parameters file. So if you look in the folder with the PNL, there's a CSV parameters. So you can create a new folder of parameters if you don't want to modify in case you make a mistake, or you can just use this one. So you'll want to copy that folder over here, and you'll want to make sure that all the backward slashes are forward slashes. Don't mess with the name though. And then you also want to make sure that there's this forward slash at the end. And that's all you have to do in the code part. And then in the parameters file itself, we have a retention time window for matching plus or minus 0.07 minutes in this case. This is for lining MSMS scans. Since it's DIA data, and you should get an MSMS scan at every single point, you could probably narrow this down significantly, but I'll let you optimize that. Then there's MZ search tolerance, so this would be plus or minus 0.007, plus or minus 15 ppm for MS2. So you can change these parameters. These are pretty wide windows just to make sure we capture everything, but if you know your mass accuracy is better, you can narrow that down. And then the intensity threshold for MSMS is usually 60 for an Agilent, but it would be 1,000 for a thermo, so on and so forth. So you want to change that based on the instrument. What intensity do you consider as real? You can ignore these two and just leave them the same. The isolation window is going to be your mass accuracy for matching your MSMS scan to precursor ions in your table. So if it falls within plus or minus 0.5 Daltons, the triggered MSMS will fall in. Again, this is deconvoluted data. Probably has an exact accurate mass for that. Now, these AIF column rows are not used. And then you need to edit where you find these different columns, the mass charge, retention time, the row ID, or comment column that should be numeric. So you have to actually open up your table which again is the one generated by the one before, which we renamed and put over here. Sorry. I don't know why. Here we go. All right, so here's the inputs. And we want our MZ, so you can highlight over. This is in LibreOffice. You can use Excel in similar ways, highlight over them, or you can count 1, 2, 3, 4, 5, 6, or see it down here. So in this case, 6 columns. Selected, retention time is going to be 7. So we want to change these parameters. So you would put 6 for MZ. Retention time is 7. Don't need drift time in this case. And then the comment column is usually, I call it row ID, but it's whatever numeric data is unique, and it's a unique number for each feature. Now, this should be the same column that you use when you ran FluoroMatch IM because it will align based on the feature number. Let's see. There we are. So here's row ID. I'm going to go Control-Shift left, and that is 20 columns. So it's in column number 20. So we want to put that there. And so these are very important to change. your data should always start at row 2. So what I mean by that is, in this case, the scores and all the mass charge retention times. Remember, these are the results already from FluoroMatch IM that we're using as our inputs. Should start at 2. So there shouldn't be any more header columns. If they are, remove them. And then you want your directory of inputs. So you can see here that this is the same. I guess so. We need to copy this directory. And then you want to also have directory of your libraries. So the libraries come with the software as well. So if you look at lipid match libraries, just go into this folder, copy that. It's not actually lipid libraries, it's PFAS libraries. So I'll actually change that before I release it to FluoroMatch libraries. And then we will put that in here. And each one should end in a /, and so there should be a blank here, and they should all have fluorescent /. So if I Control F, find those, and then replace all with /. Whenever you do that in any coding, you want to make sure that it's in the current selection only. I don't know. Anyway, I'm learning how to use this free version, Office Libre, so we'll just do that manually. If you do it manually, make sure that you don't mess up. It's probably because it's a special character. All right. In Excel and things, it won't turn into a link. And don't worry if it does show up as a link. It should still work okay. All right. So that's done. You can ignore everything after that. These are not used by the modular software. And then we'll save that, close this. And then we're ready to run. We have all our parameters set up. We have our inputs. Remember that you should remove your output folder if it's there. And you press Control A and click Run. Now, you won't want to run it through RStudio unless you link it to your actual R that came with the software. So if we look at this software, let's look again for sorry. There's this R 4.40, and that's the one you want to use. So go to x64, R GUI, and run that. And so you'll Control A, C from, and then you'll paste it in here. Control V. I'm not going to do it right now, but you would paste it, and then when it's done running, should run all the way to the end where you see stopping code here, code complete, so on and so forth. This libpass I just added, that won't be there. But this final statement, and then you know you're done. Also, you know you're done because there'll be an output folder generated, and that folder will have all of these files. It'll have neg-ID'd fin and negraw MSMS especially. Neg-ID'd fin will constantly be overridden, so do wait till the whole thing is written before you use it. The last step now is to upload these files into Power BI. So you'll want to download the Power BI desktop version. I'll show you later where you can get up-to-date instructions on running the software. But if you again look into the software, the Power BI comes with it. So you can open that up. Now you have to wait for the Power BI to load. And then you can go into this data transformation, click that little down arrow, go to data source settings. And you'll want to go and change all of the files. So these 3 files, Kaufman, PCA loadings, and PCA scores, came with your software. So you only have to change these once, and then you'll never have to change them again. So if you go to FluoroMatch IM template files, you can see them here. So I'll just grab the Kaufman, and then you want to change these the first time you run them so they're linked to your directories on your computer. And as long as you don't change where your software folders are and so on and so forth, then these will always be the same. All right. You do have a number of files you have to load in. There's actually 6 of them. 2 of them will be from the outputs that you just generated in modular, and you'd want to use these outputs. So that's the neg raw MSMS. Oops. Not from your templates folder, from your actual outputs, because you want the results. So you'll grab those. Oops. Let's close this. If you make a mistake, just go to discard changes. So you want to make sure that you upload the right. So I've already uploaded these previously. If you click discard, they'll all be discarded, so you'll have to do it again, but I've already uploaded them previously. This is not my first time running the software, so I won't upload these again, but the first time you'd have to if you click discard. So again, we want to go to neg raw MSMS. Now make sure you're in the right output folder. Get the right file. Get your neg ID'd fin file. And now these rest of these files, these 4 files, the MS1, 2 MS1 files, and 2 EIC files, these come from FluoroMatch IM run. So you have your DT EICs, your MS1s, your formula predictions aligned with your MS1s, and your retention time EICs. And then you'll want to close that, and you'll click apply. Right now I uploaded the same files that were already used in this file, but you'll see something that says apply changes. Click apply. You'll watch everything load in, and then after it loads in, you might get an error related to something related to Kaufman. Just click apply again, close that error, and click apply again, and that should work. And then you have all of this information. You can see the MSMS, the EICs, the mobilograms, the isotopic matches, the MS1 spectra, peak table, Kaufman plots. So we'll go over in another video tutorial how to look through these results and start to identify compounds using both MSMS and collision cross-section based annotations. Here you can see something annotated by IM Ability and by MSMS. In both cases, it's a phosphate-related species. And here you can see, for example, another one, both MSMS and collision cross-section identifications, identifying the same compound. Very cool validation here for all of these. And so this is a very exciting new feature, and I'm excited for you to use it and try it. And if you do, please reach out.